audio. We'll get there eventually. What I was saying for an introduction, actually, let me switch back to my video view. I can actually talk to you folks. Great. Well, we're getting a little bit closer here. Right now, for some reason, I'm not seeing folks showing up in my Google Hangouts view. So there is still a little bit of a gap in the infrastructure and how these tools are coming together. We're going to use a Google slide deck to actually go through a couple slides to talk about some of the cloud use cases. So this being our second cloud computing basics or cloud computing basics meetup. This being our second episode, we were going to talk this time about some of the cloud use cases, how people are actually using clouds, and touch on a couple of the best practices, things to be aware of when you're thinking about cloud as a technology that you might want to consume or use to actually implement or build your services. To that end, so we'll have the Google questions. There's a link at the top. Actually, here, let me jump back into that view. So hopefully now we can see our slides. And with that, we'll be able to address the specifics of any questions folks have. There's at the top of the slides here, I can turn my little arrow maybe. Yeah, all right. So there's an Ask Questions link here. You should be able to go here, and that will actually pop a question into a Q&A panel that I have. I believe that information then stays consistent with this presentation. We'll also then try to post any questions and answers that we have at the end of the session to the Meetup channel along with the slides. And of course, this video will then be available after we're done. Will be available on a YouTube long-term link. So we'll have that posted to the Meetup group as well. So, diving into it, we wanted to talk last time we talked about the NIST model, really a way of describing how cloud works, how these services interact, and how we can actually leverage some of these technologies. In doing that, we specifically focused mostly on the essential characteristics. What is it that makes a cloud? And just to sort of review that, the number one characteristic, the thing that I think that everything else sort of derives from, is on-demand self-service. Once we have that self-service aspect defined, the rest of these components are what allow that self-service aspect to really be functional. If I have on-demand self-service, I need elasticity. I need the ability to ask for more resource. Better yet is I also can give it back. That's what makes it elastic. We also talked about pools of resources. Those might be virtual. That's probably the easiest way to actually get a pool of resources. There's no requirement for that. If I have physical machines, there's actually a really interesting cloud technology company called Packet.net that provides physical compute as a part of their cloud model. So it's on demand. You can get it when you need it and return it when you're done. That's very functional. Measuring that service is also very important. From a service provider, of course, service providers would like to get paid for what they provide, so they want to measure that service that way. But even within an enterprise, measuring services are also very, very important. And then we have broad network access. Broad network access is a way of looking at how all the different resources fit together, how all those services can interact in a way that better enables the capabilities of all these services that we're enabling. We're usually talking about web scale applications or web-enabled applications. And when we enable those applications like that, we're also looking at how we retrieve and recover those resources and services. So that's the characteristics, and those sort of define what is a cloud service. What I really want to focus on today, though, is the service models. This is really how people are using cloud and cloud services. I think the one that most of us are probably most familiar with and actually do probably use the most of are the software as a service options. Basically, every unicorn startup today is really providing software as a service. So you have the Twitters and Airbnbs and resources of that nature. Now, their software is providing a specific function. So Airbnb is providing rental management and short-term stay management resources. Twitter is providing dynamic short message communication services. The bigger software as a service options are things like Google Apps, or maybe at the extreme case, something like a Salesforce, where you have this bundled set of application components that you're retrieving in that cloud sense, the as a service sense. really. So again, we have on-demand capabilities, and the little image I have here is from the Google Apps dashboard. So this is just an example of one of the many ways that we can think of software as a service. And with the Google model, this is actually one of the very common ways that people think of software as a service using the different cloud models, the deployment models. Usually this is in a public cloud or public option. So I can get access for my entity. My entity might have private resources within that public service. So here, Google Apps is a really good example of that, because as an apps user, you have access to a broad catalog of application types. And that catalog enables a number of different services and resources that you can then call from to consume within your group. And in the apps group, that would probably be an enterprise or a small team of people that are trying to work together. And that might be simple things just like a contacts database. Or maybe slightly more complicated things like a customer relationship management tool, something that helps you manage who you've talked to and for how long and what the probabilities and things of that nature are. Or managing, here there's the Google Groups component. This is software to create basically shared historical conversations. So we can get a bunch of these things from a SaaS provider, so an aggregator of software resources. But we can also use them from the community at large. There are a lot of integrations. That's one of the big, I think, shifts in the software as a service space, is this ability to integrate. And while we're talking about software as a service, there are multiple views to how this works. One approach is to say, well, we can look at software as a service as a tool set that allows an enterprise or a resource group, basically a business entity of some nature, or maybe a non-business entity of some nature, to provide a set of disaggregated, or in this case, in the Google Apps model, aggregated resources and software resources to run their business. But there's another way of thinking of software as a service, and that is from the developer perspective. Developers can actually leverage the software resources and capabilities for actually expanding their own application environment. So they might build an application within an enterprise, for example, that draws from another number of software as a service systems, specifically because of the increased ability to start integrating those software services into other applications, whether they be other software as a service options. Really common one is for that kind of integration is application environments that integrate with the data sharing services. So maybe something like a Dropbox or a Google Drive or a Box.net. These services are principally focused on, these particularly software services are principally focused on ways of managing files, potentially managing large files, and providing access models so that those files can be easily retrieved and shared amongst other resources. So that, and those services have their own software interface, their own web interface, usually for providing access to those resources. But they also have an application interface that a software developer can consume to integrate that resource into their environment. A common example of that is Slack as a software as a service entity, which is a collaboration tool if you haven't run into that one, that people are using as a message bus. So receiving messages from an application and potentially even having another application monitor that feed for then interacting with the environment. But from the perspective of like the Google Drive or the Dropbox-like integration, you can take that messaging software as a service, right? You're sharing it amongst a group of folks, and integrate the Google Drive function in so that if you post something from Google Drive, you don't actually have to copy it into Slack as an application. So you can actually manage your data still in the Google Drive space, but you can share it within the Slack space so that people then have access to that particular resource. This is a really interesting approach to using cloud. I don't actually have to go buy virtual machines or physical resources and share those in a cloud sense. I can actually just share software resources and integrate them together. This probably is the biggest consumption space of the cloud environment of just about all of them. And in fact, there are now even companies that are building software as a service tools just to manage the interaction of software as a service options. A really common one is IFTTT, if this then that, which is an application environment. Zapier is another one. There are multiple in any one space, but these are companies that are basically building little workflow engines, little tools that go from point A to point B by integrating all these different resources together. So again, very powerful tools, and this is looking at software services. So again, elastic, on-demand, monitored, etc., or metered, etc., just like any other cloud service, but it's software services. And as you can see, there's a broad spectrum of what those use cases might look like. And I've just given you just a couple here to sort of mull over and think about how that might apply to your own business. Now, again, before I continue on, if you want to ask a question, Google Slides ESC8RE. Wow, that's a really easy one to remember. But that quasi short link at the top will allow you to actually request or ask a question, get some clarification if it does or doesn't make sense. Now, another model in the cloud space that people are looking at when they're looking at how they consume cloud is the concept of platform as a service. This is one of the more developer-friendly rather than end-user-friendly environments. But it's really interesting because it abstracts the infrastructure from the development environment. Really, the focus of platform as a service is offering those intermediate stages of resource. Maybe I don't want to actually manage a database, but I need a way to store my data, and a relational model for my data is a very sensible way of doing that. Or maybe I need something that looks more like a messaging service, like a publish and subscribe interface, pub sub as they tend to call it within the development space. Having access to those resources but not actually having to manage those endpoint resources is actually a really important aspect in the platform space. So a platform is often comprised of a number of these service capabilities with some form of a deployment or enablement model wrapped around that. Now, two of the more common ones that are out there today are things like the Red Hat OpenShift platform, or the and that's one that you can deploy as an entity on your own, so you can actually deploy your own platform as a service using OpenShift. Or there are platform as a service services, which would be things like the Heroku platform as a service as an example of that. Really, these are leveraging a technology that's gotten a lot of buzz lately called the container environment. Containers being a way of managing software processes in a secured fashion, something that maybe we'll talk about in a future meetup. But the container service and that container engine is one that enables software to be bundled together in a very efficient fashion. And the platform as a service engines, these OpenShifts and Cloud Foundries and Heroku tools tend to do that. So what they require as input is a set of descriptions of the resources needed by the particular application, and then they manage a number of the additional services on top of that. The nice thing is that you're consuming compute resources and potentially all these other resources, but in a more managed fashion. So the platform is being managed for the end users. They don't actually have to build it. As I mentioned, platform as a service really is a developer-centric environment for the most part. There are some platform as a service offerings that are out there that are maybe a little bit more for the business user. So a business user can use a business platform as a service to manipulate a set of basically predefined services and map them together, almost in the software as a service play, but with a little bit more development component to it. So there is, in just about all of these cases, a fairly strong development environment or resource model to it. But when we talk about the developer requirements, we're often looking at how can you actually build things like a minimum viable product service. How do I get the basic pieces working? And often the development model actually has a lot to do with how you can consume that platform as a service. The common ones that I talked about, the OpenShifts and the Pivotal Cloud Foundries and the Herokus, these systems tend to actually focus on an MVC style application. That's the model view controller style application deployment, where there's a model. So I have data services, so I can segregate out my databases. I have controller and view engines, and sometimes those get collapsed. But the controller and the view are how do I actually expose my resources? What kinds of services am I exposing? And how am I actually running my business logic? And because the MVC model allows you to somewhat segregate those resource domains, I can then create containers, basically create bundles of resource and integration that that can be defined and that can scale. Because that's the other real aspect here, is that we can actually now more easily scale the front and back end of these services by basically ramping up individual resources and mapping those resources in a scale up or scale out kind of a fashion. Often the platform as a service engines require that you describe not only your application, but your application integration requirements. So for example, if I'm going to use a database, let's say I've decided I need a relational database. So MySQL or Postgres might be examples of those relational databases. I'm not going to manage that database, but I expect to have an interface to a database as a service offering that allows me to describe the schema, the relations that I would like to store in that database, and bundle that together with my actual application code itself. And in doing that bundling, I actually then describe not just the application, but the libraries that application might require. So maybe there are some database manipulation libraries that it requires, and also some presentation layer libraries. So maybe I need to incorporate a set of JavaScript application components or JavaScript libraries that are not part of my control code, but are part of my view code. I need to describe all those pieces, bundle that up, and then serve that to my cloud platform as a service offering. So these services enable application deployments. Often those application deployments turned into, guess what? Yep, you guessed it, software as a service options. Now, building a software as a service infrastructure is not necessarily as easy as just deploying on top of a platform as a service environment and exposing an API and potentially a web interface for end users to consume. There's a lot more that goes into managing users and segregating resources, but it turns out that there are now platform as a service offerings that are starting to support some of the software as a service enablement resources. So for example, managing users, managing tenants, these are things that need to happen in your software as a service environment, but might not be part of a normal software as a service, or rather, sorry, they would be needed for you to build a software as a service environment, but are not part of most normal platform as a service offerings. Usually those are things that you would actually have to develop yourself. So there is another extension of this. This is actually fairly, I think of it as fairly new. It's been over a couple of years now where this has started to become available, but we're starting to see people talk about platform as a service and a slightly different version of infrastructure service. So we'll talk about infrastructure as a service next. That's sort of the third of the NIST Model 3. But I wanted to talk about container as a service because, as I said, the platform as a service model effectively is looking at containers as a way of managing and manipulating the application environments that an end user provides. Well, container as a service takes the same general principles as platform as a service. This idea that maybe you're disaggregating your application into little bundles of basically control code. How do I actually get my application to do my business logic? And then describing usually additional services that I would like to interact with, like databases, like scale up, scale down services like load balancers. But there are some folks that have decided from a development perspective that they would like a little bit more control over how those containers get built, defined, deployed, and run. And so we're seeing container as a service as a descriptor for a variant of the platform as a service space that really focuses on bundling containers together. Now, a container is really a software packaging exercise. So it fits really well in the platform as a service space. And in fact, the platform as a service engines that I mentioned, the Cloud Foundries, the Herokus, and the OpenShift type services that exist today, in general, are building a bundle of resource and running that bundle in a container. The nice thing about the container in that sort of a process space is that it really is a software function segregation model. The container is, so I've segregated my software resources, and at the same time I've bundled up all my application requirements into one nice software package that I can then go deploy in places. We're seeing a number of companies like Amazon, the Microsoft Azure Cloud, Google Compute Engine and Google Cloud environments, and plenty of others are offering containers on demand. So a way to actually let you manage the bundling and resource management of your application, which is kind of nice from a development perspective because you can now develop in exactly the same sort of systems environment as you would actually go into production with. And it makes a lot of sense from a developer lifecycle perspective. The other interesting thing about this, I think, is that we're seeing what I think now is the beginnings of true hybrid cloud capabilities. When people have talked about the hybrid cloud deployment model, they've often talked about having public and private and potentially even community cloud access for running your applications, because in the end, really what we all want to do is run an application to get our business to work and to get our business to grow. Well, in the hybrid case, the concept has always been that you could use public services and private services, or maybe virtual private services, so a public service but with a private boundary wrapped around it, to actually run applications as they need to be run. So I might need to scale an application up or down. Well, the container model works really well for that. So in a sense, the platform as a service model works really well for that. But there aren't many platform as a service engines that allow you to take your description of your application and run it in a private sense and also in a public sense. Cloud Foundry has both public and private models. So there's a public and private model for that. But I haven't yet seen really good migration technology to go from one Cloud Foundry cloud to another without basically just deploying it again into these environments. With the container as a service model, you can suddenly create a hybrid cloud where you bundle those resources together into your container, store it in a shared online repository. So this does usually have to be a repository that at least has cloud service access. So a private Docker hub would be one example of that. And from that shared repository, now you can deploy into your private environment or into your public entity, and have a shared control plane that potentially maps over top of all of that. That's really the promise of hybrid cloud. And I think with the container as a service models, we're finally starting to see that really come into play. So that's actually a really big shift that's happening in the systems environment. So this leads us to what I still think of as the biggest play in cloud still today, and that is people deploying virtual or physical resources in infrastructure as a service systems environments. A really common infrastructure as a service environment today is the OpenStack environment, that being a public service to provide infrastructure. From a cloud provider perspective, there are the Amazon. Well, Amazon is still the 1,000-pound gorilla. Then we have companies like Google and Microsoft Azure are sort of the second. I think they're still considered the second tier, but they are large entities that are providing cloud service, and they provide a broad range of services. But all of these guys, including some of the smaller but still large players, companies like Rackspace, DreamHost, DigitalOcean, companies that provide cloud service, and none of these are necessarily running on top of OpenStack as their cloud resource, although Rackspace, for the most part, is. The point really here is that there is then this need to manage virtual or virtualized physical infrastructure as a part of the cloud service model. OpenStack provides a good model of that. Actually, OpenStack was based on the Amazon model, so in a sense, Amazon provides the best model of it. It's the initial model for these services and capabilities. And what we're really seeing is this goal to enable the ability to deploy resources without approval. Right? This is sort of the intro, the beginning drive behind the infrastructure as a service, the cloud services system space, this on-demand capability. Well, here we're really talking about on-demand capability against infrastructure, compute, network, storage resources principally. We might be talking about network services, so there are network functions like load balancing or firewalls or VPN termination that might be a part of it. There are multiple storage models, things that are ephemeral and low cost and not necessarily highly performant, and super performant services as well. So very high performance database backends and small and large compute entities. All of these resources and models of these resources are a large part of how the infrastructure as a service solutions provide compute, and a lot of people are using them to bypass ever having your own private environments, your own private services environments, basically bypassing physical IT for many companies and many customers. This on-demand capability is really what's driving cloud deployments today. And again, when we look at infrastructure as a service, and really any of these environments, infrastructure, platform, or software as a service, we see that there are a number of use cases. I think infrastructure as a service people still have in the back of their mind that it is the most flexible because it gives you the ability to define what infrastructure is available. Yes, a provider might have a list of infrastructure components that you could leverage to build your application. Often those are enough to actually implement the deployment across a large scale, a large, excuse me, a large number of resources and folks over time. And that infrastructure as a service use case list actually does sort of percolate over into the platform services space. As I said, especially with the concept, some of the bursting concepts that are described in here, they're almost better in the platform as a service space, or this thing that maybe falls between the two, containers as a service, as a systems model. So again, as I go through this, if you have questions, please go to the to this link here, Google Slides ESC8RE, and go ahead and drop your question into the list, and we'll get to that as you present them. So of these use cases, these are just some high-level models that folks are looking at. And again, like I said, they fit both the infrastructure service and the platform and potentially even the software as a service use cases, because you can map all these resources together. So if we talk about sort of the initial one, the development stage and testing use case, this is probably the initial way that most people get into using cloud resources, and often becomes some of the largest cloud consumption within an enterprise. The metering and monitoring of those resources is probably also one of the biggest areas where folks lose out on their cloud, lose out on the functionality and flexibility of getting value out of their cloud, because often those resources are not as well monitored in terms of actual consumption and actual use, versus an actual production use case where people are paying very close attention to how much resource is being consumed, how often it's being utilized, is there too much deployed, should we deploy more to address potential performance issues or concerns from customers. So when we're looking at those use cases, we're seeing a shift towards being better at monitoring the overall resource as a way of dealing with these environments. But again, development, stage, test, these are all environments that provide that function very well when you have a highly programmable environment. The programmability is something that we haven't really talked about much, and it's not a requirement for cloud. Cloud defines on-demand and self-service, but does not say on-demand API-driven self-service. Now, most cloud services these days that are truly scalable, truly flexible, and integratable have an API of some nature, or at least have some form of command line interface that can be used in lieu of an API in the absolute worst case of these environments. But that programmability allows you to take a development pipeline that used to be somewhat manual. Somebody would write some code and then commit that code potentially into a source repository, and then potentially manually run a set of tests. Now we can use triggering components of the repositories, triggering components of management tools like Jenkins or Atlassian Bamboo, managing those resources, managing the automation of development and test, and potentially even all the way into staging and into production in some cases. But that life cycle of an application and automating that life cycle of an application, the ability to say, well, I want every time I have one commit into my repository, or 10 commits, or 100 commits into my repository, every time I get some set of code delivered, I would actually like to automate the deployment of a test environment, deployment of a staging environment if those tests all pass, and potentially even deployment then into my production environment. Automating all of that is something that the infrastructure as a service, and to a certain extent platform and even software services environments, enable, because they are now API driven. But it's the on-demand aspect that makes it possible to scale those environments out. And really was one of the principal reasons that companies like Amazon were able to make their web services, their EC2 compute services, functional and scalable for their end users. Another thing is the deployment scenario. So this again takes its lead from this concept of development and test and extends it further and starts talking about deployment, talking about services and resources that are actually being enabled in that sort of an environment. And really looks at the life cycle of going into production and then monitoring and maintaining that production. One of the nice things about the infrastructure as a service model for production use cases is the ability to actually have multiple sites automatically available for you. So you can develop in one site and validate that the service works, maybe even develop in two sites to validate that the high availability services work. But then when you go into production, you have those multiple sites available to you. And just about every cloud provider from a service provider perspective has at least two locations from which you can get resources from the services. And even when you're deploying private cloud, it turns out that having multiple resources is potentially easier because you can share physical resources that used to be dedicated to a specific project. You can potentially share those resources much more effectively through infrastructure as a service offerings. Now, the web hosting and viral marketing case, this really is a marketing-driven use case of cloud service. A good marketing team will want to try to figure out how to scale out and extend their resources without having to necessarily call in additional physical resources for a project. The concept of viral marketing and the concept of something suddenly taking off in the internet sense is really an important aspect today. And tools like cloud services, this automatic ability to add resource into an environment, is becoming increasingly important in supporting that model. Without actually having that sort of scalability, the elasticity that cloud provides, whether it be a private cloud that an enterprise runs potentially in multiple locations, or leveraging a public cloud for that use case, having that service availability is a real key component. Another concept is the concept of high performance computing. And now this could tie into things like geospatial data modeling and weather modeling, things of that nature. But in reality, most people, when they're talking about high performance computing, they're talking about ways of scaling out things like big data workloads and other projects that used to take large chunks of corporate resource, large chunks of your physical resource, but might not be full-time needed. This is where the scalability and elasticity of the cloud really comes into play. Now, often things like data sets don't scale down, they scale up only. But a data set that's stored in a cloud location lets you potentially leverage cloud resources to compute latest sets of changes against those resources, or potentially even start doing some more of the streaming sorts of analytics against data resources. And the high performance computing resources, the batch concept is really where that sort of came from, or at least the concept came from. And in the batch case, certainly the elasticity, the ability to add and remove capacity is really important for batch. Maybe I keep a small set of systems always running, trying to keep basically long-term analytics going. But when I want to do a deep search on something, I can actually scale my resources out against my data set so that I can actually get the response faster. So things that used to take on a single computer a week might take on 7 computers only a day, and on 70 computers might take an hour. And it's that kind of scale out of a performance requirement that means that, hey, maybe 70 computers for an hour is actually a lot cheaper than having paid for a single computer that sits in my data center but only gets used once a week. And that's really sort of what drives the high performance model of infrastructure service. That same model can be applied to any of the software as a service, platform as a service kinds of use cases, but it really fits best in the infrastructure service space. Now, I will actually flip these last two and talk about disaster and backup and disaster recovery. One model in the cloud space is to say, oh, well, you should never really have a single entity that would fail, causing a disaster recovery requirement. In other words, your service should be scaled across enough data centers that the worst case scenario you would have is that your disaster recovery model is to deploy more services in another data center to address the systems load that you're seeing that your initial site, that your failed site didn't actually address. But there are still folks that are looking at how they deploy their classic enterprise applications in the cloud environment. And for those services, the concept of backup and the concept of disaster recovery still applies. Now, one way of thinking about that is that maybe within your enterprise, you still have your production system, but your disaster model, your disaster recovery model is to actually migrate all those services automatically into the cloud. To do that, all of the things that you would do with a disaster recovery environment would still apply. You're still going to have to create snapshots or create a stream of updates that get sent to your disaster recovery site, which means your cloud site, which means that you are consuming cloud resources. It's not like they're sitting there completely idle until you suddenly need them. But the nice thing is that maybe you're just running the disaster recovery backup engines, the streaming data capture engines that are providing a resilient data source for your services, the rest of your environment can actually be in a shutdown state, so it'll be a lower cost option than having those systems running full bore all the time. Now, some service providers actually charge the same if the system is running or not, so you don't necessarily get as much benefit from that. But you can also look at applications that can scale up and down. So if you have an application that you're looking to provide disaster recovery for that normally runs across 10 or 20 physical compute entities or virtualized compute entities within your data center, maybe you only have one of those entities running in the disaster recovery location, providing that consistency and coherence to the data set. And it only scales up when it's actually needed. That kind of model is what allows infrastructure service to become a very flexible disaster recovery site for those services that still need to think in the disaster recovery model, which is a lot of enterprise companies today. Now, I also said that there was temporary capacity and bursting, and in the previous slide or the slides previous to this, I talked about container as a service maybe being the answer to the hybrid cloud use cases that people have. In the past, when people talked about hybrid cloud, before containers really came onto the scene and people talked about container as a service as really being a viable business option, we actually saw that people were looking at how they would actually migrate a virtual machine into the cloud, run it, and then potentially migrate the data back out of the cloud. Honestly, I think this use case has never really worked. Certainly the scale up, scale down bursting capacity capability from the high performance compute perspective has made sense. If I store my big data workload, for example, in the cloud, I can scale it up. If I store my big data workload, my data set in my private cloud, and I want to then use the public cloud as a way of bursting, my problem is getting access to that data set. My problem is getting that data set to somewhere where the compute resources aren't sitting there waiting for low latency or high latency networks to actually deliver the data that they want to process, basically not getting the best value out of your compute resource in the cloud. So the concept of bursting, I don't think works very well from that perspective. But the concept does work well when we start thinking about things in terms of containers, because our containers are often very lightweight. They're not these 100 gig megalithic application virtual machines that would need to be moved around. They're potentially 1 gig or less. Actually, often they're in the order of hundreds of kilobytes, if not even 1 or 2 megabytes in size. These container models are much more realistic for actually being deployed and spun up. Now, the data still has to be local to the compute resource to be most efficient. It's not that it can't be remote, but to be most efficient, it has to be local to that resource. And from that perspective, actually storing the data set or replicating the data set into multiple locations, depending on your bursting class needs, is an important aspect to thinking about how cloud works and how cloud might actually scale. So these are some of the principal use cases that we see in cloud. We've talked about software as a service. We've talked about platform as a service, and we've talked about infrastructure as a service, and then we've talked about some use cases within those environments. There are also always cases where you say, well, maybe the cloud isn't the right answer. It is an important aspect to keep in the back of your mind. Cloud does not solve all ills. It does not fix all problems. There are options like using a container as a service or even a virtual compute management environment where the IT department still actually manages the deployment, manages the operations, manages the resource consumption. These are not cloud models because they don't actually use the on-demand self-service aspect of cloud, but they use these virtualization technologies and they use the management models. We suddenly have that automation that an ops team can potentially do to manage an operating environment. That may be actually all that the application needs to be most efficient and most effective. And that's great. If that model fits, that's fantastic. There still is the model of managed IT. That is not going away. And there are still plenty of applications that the application developers don't have the knowledge or the understanding of the infrastructure to actually operate the infrastructure, or the infrastructure has been built over so many years and is effectively something that actually has to be actively maintained to keep it running. These are environments where we're still going to see people not able to use the cloud. But really, self-service has changed the game. It has changed how people think about resource consumption, resource management, and resource environments. And I think this alone is one of those things that really drives the value of cloud, is that while there are these alternatives, most people want to try to find a way away from them, whether it be a public resource or a private resource or some form of hybrid resource that fits between the two. So in sort of summary, as a way to sort of close out this discussion of use cases and how people are using cloud, I wanted to talk about some sort of gotchas, best practices, things to consider. Basically, this is my list of 5 ways to fail at cloud. Number 1 is to ignore the concept of chargeback or metering in a private cloud deployment. Certainly in the public cloud, you're going to get charged for what you use. And having used public cloud resources and forgotten to turn them off because it was too late at night when I was doing development and I didn't have an automated way of saying, hey, this resource isn't being used, let's go ahead and collapse that resource or delete those resources, because I've built my environments as a way in a way that I can actually automatically redeploy them all the time and get back to my current working state. Having that back pressure to actually release resources is the number 1 way I think that people can fail at getting to cloud and making a cloud use model really effective. A really good example of that, I was talking about the development use case, how people develop, how people use resources like that. And the number 1 thing I've seen in that development use case is that when people think to develop in cloud, they often forget that those resources cost. The developers don't necessarily see the bill. They're the ones that are trying to get something to work. And giving them the on-demand capability is incredibly powerful because they can actually use that to get their work done. But doing that within a private setting usually is where this chargeback piece fails. It often leads to complete consumption of the resource space with no capacity for elasticity because resources don't get returned to the pool. Providing a chargeback model or at least some form of update to the development managers or even the developers themselves is the number 1 thing that you need to do if you're looking at private cloud. And I think the same thing applies to public cloud use where the developers don't necessarily see the bill. Providing them visibility into how their consumption is affecting the bottom line, especially in a startup where dollars do matter, even if money's being thrown away on foosball tables. Still understanding how your resources are actually affecting your ability to continue your startup is a really important aspect to cloud. So number 1 way of potentially failing. Number 2 is no realization of what self-service means. Often people think that self-service is a way to turn a resource on and leave it on. To me, that is a failure almost as dear as not having knowledge of how your resources are being consumed. And what I mean by this is I have seen plenty of use cases where people will deploy a machine and leave it running and just assume that that's cloud. Now, you probably have production workloads that will never be turned off. That's fine. And deploying those in cloud, if the operations model makes sense, in other words, I don't have to operate the physical resource that is running my cloud. That is always maintained and managed for me, and so therefore I can run my environment in that sense. For small numbers of even physical compute resources, managing them in the cloud makes a lot of sense. There's an ROI calculation that can be done and can be looked at and determining when that makes sense. But lacking the concept of what self-service really means often causes this to fail. And self-service, from my perspective, means the ability to give back, the ability to return a resource. One of the things that I've done in classes that I've taught is to actually force people to do that. It's so easy to get somebody to spin a virtual machine up, but then they become attached to it. It becomes a pet in the pets and cattle analogy that people use for cloud. Even though nothing is running on it, even though potentially they can't even get access to that resource, they suddenly think it's their resource, rather than thinking of it as just part of the pool that you will use as a tool, right? It's like saying, hey, I have to have my own screwdriver rather than sharing a screwdriver from the community. Well, that is the number 2 way of failing, because you start to consume resources and assume that they're yours even when they're not needed. And it fails the chargeback test as well, because you don't think of returning those resources and potentially recovering elasticity, recovering resource in the field. Now, I'll admit, most service providers would be very happy if you never returned any of their resources and just continued to pay. But from the perspective of actually using that cloud and sharing those resources in the most efficient fashion, this is a number 2 way of failing. Number 3 is ignoring the need to operate the cloud. Just deploying a machine into the cloud, especially if you're deploying at the virtual machine level, really does not force value in that operation. It's really kind of interesting to see that you have to actually still actively maintain your resources. Less so in the platform space, even less so in the software as a service space. But it still comes back to, are you using those resources efficiently? Are they functioning at peak efficiency? One example is often if you spin up a virtual machine in an Amazon environment or even a Google environment, etc., any of those compute-based resource environments, because you're sharing physical hardware at some point with a number of other resources, it might be that even though you have access to the resource, you're not really getting the best value from that resource. So not being aware of operating your application from the perspective of how the cloud works is another way to fail at actually getting the best value out of the clouds that you deploy. Another one, and this is classic, is assuming that a pet-based application, so an application that actually requires really tight controls on the infrastructure, on the stability of the infrastructure, on how the application itself gets deployed, managed, updated, upgraded, etc., and trying to run that in infrastructure that is not designed to support those use models is a clear way of failing, because there's a really good chance that your application will become unavailable due to an infrastructure change that a cattle-based application, an application that is designed to be resilient across multiple sites, across multiple VMs, across multiple deployments, could actually withstand. And that really comes down to understanding the architecture of clouds, understanding how clouds work, understanding the value of the cloud infrastructure, and mapping that to how your application works. It might be that in order to deploy an application into the cloud, it actually needs to be rebuilt, or at least needs to have some of its architectural components remodeled and restructured so that the cattle mentality, it's not always going to be functional and running mentality, actually becomes a way of thinking about the application systems environment. And the last way to fail, way T to fail, I guess I need to fix my slide. The last way to fail is really business as usual. Again, this sort of falls into the previous category, but thinking that I can continue to use my resources the way I would have in the physical world, but in a virtual world, and especially in a cloud-enabled infrastructure or platform services world, will guarantee you a way to fail at just about all of the things you might want to do. I wrote a recent article on how to fail at running an open source project, not even OpenStack or an infrastructure or a cloud project, but just not realizing that to use these tools requires a different way of thinking about operating, a different way of thinking about resource utilization and consumption, a different way of thinking about the sorts of things that you should be doing and can now do with your infrastructure. For example, assuming that you should have a separate development team, a separate test team, a separate QA team, a separate production management team, those resource groups really should start looking at how they integrate together, leveraging a shared cloud resource space to make all of their jobs better. That doesn't mean that those four different entities, for example, development, test, stage, and production, doesn't mean that those groups would have to integrate into one group, although there are some benefits that you might garner from doing that, but rather that those four resource groups should start thinking about the cloud as this programmatic, on-demand, functional self-service engine that can enable them all to get their jobs done more efficiently together rather than as separate groups and entities. And so with that, I've actually covered the technology and the topics that I wanted to talk about today. And I think we've talked about a bunch of different things in terms of cloud use cases. We've talked about software, infrastructure, and platform models. We've talked about how containers are sitting now between the platform and the infrastructure space a little bit, but really sort of fall into a different version of infrastructure as a service in terms of how they get consumed usually, and how the container model also is potentially changing how people think about the possibility of real hybrid public-private cloud interaction use cases. And then I think this was the other sort of big thing, is looking at some of the best practices and gotchas when you're thinking about using or leveraging cloud. These are from people that I have seen fail in trying to deploy into cloud resources, and fail because they're not understanding what cloud means, which is exactly the sort of thing that I hope that over the coming months we continue to talk about in this meetup. So with that, I'm done. Again, I don't think that I have the ability to turn on the microphone for folks that are on the meetup. Let me just see if, yeah, for some reason I still only see myself in this environment. But if there are questions, again, the best way to ask them right now is through the Google Slides link, which is at the top of the presentation that we can see here, that's right here. So if you do have a question, now would be the time to ask it. I'll pause and see if anybody has a question that they would like to ask. Great. I did have somebody say thanks. I think I can do this. Ha! See, I can present it. Yeah, thank you as well, folks. If there are no questions, again, I'll wait for a moment and see if anybody else has something that they would like to ask. But if there are no more questions, thank you all again for attending our second Cloud Computing Basics meetup. We are actually looking at hosting this live in the San Jose area here shortly. We think we have a location that we can actually finally host a live meetup. So for those of you that are in the Bay Area, we will of course continue to broadcast this and continue to do these meetups in this fashion as well. And I think over time we'll keep getting better and better at doing it, so that hopefully we don't miss things in the beginning. And I'll figure out why it is that I can't actually let people talk directly. Again, thank you all so much for attending, and I look forward to the next session. Okay, well, it looks like there are no more questions. So once again, thank you very much for attending, and we'll see you again next time.